I would encourage you not to write everything down, as always. You guys have heard that little lecture before. You know, probably, this is just sort of, more than anything, it's a reminder to me what I should talk about. If there's something that you think is important, you should jot it down. And certainly the examples that we're going to do shortly, I would suggest jot down. But you probably don't need to write that whole paragraph down. So in the expression F equals ma that you learned about in grade 9, the A can be interpreted as the total resultant acceleration, which a body receives when acted upon by some total force whose magnitude and direction are given by F. So in grade 9, we just gave you a force and a mass, and we said find the acceleration, or some sort of combination of that, right? Well, now we're going to expand, and we did this in grade 11 certainly, where we've got multiple forces, because the acceleration, there is only one acceleration, right? There's one object and one acceleration. But when there's multiple forces, those multiple forces combine together to result in this acceleration. And the sum of all those forces is called the net force, right? Since force is a vector quantity, the total force acting upon an object is the vector sum of the separate forces that are acting. So here we go again, we're adding vectors. Can we add them by components? Yeah. Absolutely. Which we sort of kind of did in grade 11. I didn't come right out and say it, but anyways. And it is usually called the net force. Now, grade 11s tend to get all confused about F net equals. There's multiple formulas that say F net equals, and they get all fired up about that, right? But you guys are wise now, you've been through that. You know that F net is simply the sum of all the forces. So generically speaking, the net force is the force 1 plus the force 2 plus the force 3, and if there's more than that, you add them all together. And these are, of course, all vectors, right? Okay, so in other words, when you're trying to find the net force, add all the vectors, or add all the forces. Okay, here's the worst, simplest example of all time. Please don't write this down. The ability to play tug-o-war. Each one is pulling with 75 newtons, and neither one's going to win, right? 75 one way, 75 the other, negative 75. What's the net force? 0. Tough one. Don't need to write that down. Don't even need to calculate it, I'm hoping. But the question in blue, is this object moving? Connor says could be. Depends? Oh, okay. But then the net force wouldn't be 0, right? Right? So what do you mean, Connor? It could already be in motion. For some reason, they might be moving. Or maybe they're pulling tug-of-war on a moving flatbed trailer down their street. Right? And from the frame of reference of the side of the road, they are moving. So it could already be moving. Well done. Okay. What if they decide to work together and they're both pulling in the same direction? Gee, golly, you add them together, 75 and 75 is 150 in the same direction, right? The net force is 150. Surely we don't need to write any of that down. In real situations, friction is often a force that reduces the net force, F net. This results in the formula F net equals Fa plus Ff, which is really just F1 plus F2, because there's only two forces. But I've relabeled the 1 and 2 with applied and friction force, right? That's all it really is. And recall that Ff, like all forces, is a vector, so it being in the opposite direction will have a negative sign associated with it. So I like to write Fa plus Ff, but then make the Ff, put it in brackets, and make the Ff actually negative, right? Because if you put Fa minus Ff, it kind of implies that it's a different formula. Does that make sense? So let's write it like that. Okay. Let's write this one down. And I apologize for not having it copied out for you, but it won't take you long. So if you haven't written anything down by now, you should at least write F net or net force or something other as your heading, maybe the date, and then jot that down. Okay. So 10 kilogram object being accelerated by a 10 Newton force. At least I think I do. No, nothing there. The force of friction is 6 newtons. What is the resulting acceleration? So this is pretty simple stuff, right? First thing, F net is Fa plus Ff. Applied force is the 10, right? Accelerated by, the force of friction is 6. Let's write it as plus minus 6. So that's a net force of 4 newtons.
And then to find acceleration, F net is equal to ma. So 4 is equal to, it's 10, that's convenient. When I divide by 10, I just move a decimal place. 0.4 meters per second squared. Awesome. A 3 kilogram object is going 5 meters per second at t is equal to 0 seconds. 4 seconds later, it's traveling at 2 meters per second. What force of friction is acting? Maybe we should draw a free body diagram here. We practiced them yesterday. Weight force, normal force. But there's no applied force, is there? Right? But there is a force of friction. And we're going to just assume it's moving from left to right because we live in a left to right world. Here in North America anyways. So in fact, the net force here, oh, and you guys got to write this down, don't you? I'm going too fast. Okay, so what I was about to say was that the net force is the friction force, right? The net force is the friction force. So we got to find out what that net force is. We can't get to it by adding forces, so then when we get to the net force is to use F net equals ma. We got the mass, we don't have the acceleration. Can we get acceleration? 3 kilogram object is going at 5, that's the initial velocity. 4 seconds later, that's our time. Final velocity is 2. So we can write, so in fact, let's write Vf equals vi plus at. The final velocity is 2. The initial was 5. Solve for acceleration. Time is 4. Little math review here. How do you solve this? Got to get rid of that 5 first, right? Take the other side. 2 minus 5 is equal to a times 4, or 4a. Right, so you got minus 3 is equal to 4a, and I'm showing way more work than I like to. Minus 3/4, or minus 0.75. You should, in grade 12, be able to go from that to that. I really hope so. Maybe not today, but eventually. And now that you have that, F net is equal to ma. Solve for F net. Mass is 3 times minus 0.75. And the net force is 3 times that, so that's going to be minus 2.25 newtons. Also pretty straightforward, right? Again, as I was saying earlier, kind of review today. Going to get harder next week. 5-day week next week? I think so, eh? Okay, is this the last one? Yes. Okay, I'll give you a moment to jot this question down. This is the most challenging one we'll see today, but yet doable. You should have seen something like this. This would have been the hardest one you saw in grade 11. All right. So here we have a force of 50 newtons applied to a 10 kilogram snow sled at 30 degrees above the horizontal, so at an angle. The force of friction present is 18 newtons. Find the FH. You know what? I'm going to change this right now. I'm not calling it FH anymore. I'm calling it FAX, right? X component of the applied force, the F net and the A. So how do we find FAX? Well, it's this right triangle here. Because it's adjacent, it's going to be the cosine, right? So that's going to be FAX is equal to FA cos theta, or 50 cos 30. That sounds about right, 43.3. So only 43.3 newtons is actually pulling it sideways. The net force now, so now you're looking at these two here, right? Now, is there a weight force and is there a normal force? Yeah. Are they balanced? Yeah? Do they matter to the question? No. So we can kind of ignore them. We're only really concerned with the x components, right? The x forces. So F net, and I guess technically, maybe I should start doing this. This might lead good into projectile. So I'm going to say F net x. Is that going to be okay? That the net force x is equal to FAX plus FF. So that's going to be 43.3 plus minus 18. 25.3 newtons. And now we go F net is equal to MA. .3. The mass is how much? Okay. Divided by 10. 2.53 meters per second squared. Okay, so I just wanted to do that, give you that opportunity to review those x components. Pretty straightforward, Shaden? Especially a guy that just came from grade 11, right?
Yeah, and I got the cheat sheet right here.
That helps. Okay, now if I added a little bit of kinematics in there, if it started from rest, find the displacement after 4 seconds. So if it started from rest, that means that the initial velocity is 0. We're solving for the displacement, the d, the time is 4. And I just calculated the acceleration, right? E equals VIT plus 1/2 AT squared. So that'd be 0 plus 1/2. What was that acceleration? 2.3? 2.53. 4 squared. $20.2. 20.2 meters. Easy stuff, right? Alrighty, so I handed out some problems to work on. I'm not going to say it because that'd be cheesy, but yeah, but I'm not going to say it, Connor. You can just say it in your own mind. Yeah.